Hello students, welcome back. We completed up to section 4, but before starting section 5, let's have a brief recap. In section 1, we went through the necessary foundation, what it means by graphs of equations, what it means by a point is on there, no, intercept, symmetry, those kind of things. The general foundation basically. Section 2 was about technology tools, so no in-depth, just experience. And section 3, well, all review, not really of any of our class time. Section 4, minimal class time only. I mean, not more than any of those. Now, section 5, finally, we are reaching something that is worthy of our class time. So you can consider this is a real deal. Section 3 and section 4 are, what can I say, we are just going through. Okay, all right, let's talk about multivariable equations with a special property, variation. A direct variation equation corresponds to a sentence, a quantity y varies with or proportional to, those kind of things. And it goes like this. Y is k times x, where this k is called the proportional constant. No addition, that's important, just multiplication. Inverse variation is k times 1 over x. We say quantity y varies inversely with x or inversely proportional to, those kind of terms. Again, k is called the proportional constant. No addition, no subtraction, this is important. Multiplication, then it's called direct variation. Division, then it's called inverse variation, or multiplying the reciprocal. Let's see, do we have an example problem here? A monthly mortgage payment M varies directly with the amount borrowed. B. If a payment of a 30-year mortgage is $665 for every $1,000 borrowed, find the monthly payment when the borrowed amount is $120,000. So 1,000 times something became 120,000. Multiply the same thing to 665. So how do you get the answer? 665 times 120. That's what you're looking for, right? Is that clear? 1,000 times something, $120,000. Of course, we multiply by 120. So direct variation means multiplication. So 665 times the same 150, and that's gonna be the payment if you borrowed 120,000. By the way, what is this quantity? So 798. So that's gonna be your monthly payment, excluding the escrow, just a mortgage payment. Now you can answer like this, and we can call it a shortcut answer, but frankly, I do not recommend it. It's okay, it works, but frankly, I do not recommend it. I'd much rather go with a bit harder route so that you are a bit more well prepared for something that is far more important, joint variation. So let me show you the standard solution, and that revolves around finding the proportional constant. Y is kx, and then finding k. So how does that work? Well, the payment P is proportional to the borrowed amount B. Okay? So that's a proportional equation. If borrowed amount is 1,000, then payment is 6.65. From there, what is K? That's what you want to find out. So how do you do that? Well, let's put those numbers in. Payment is 6.65. That's K times borrowed amount 1,000. Which means K is 6.65 divided by 1,000. And then if you write that into a decimal expression, okay, that's what I'm gonna get. So okay, alright, we found out this proportional constant. Therefore, this provisional equation, as a matter of fact, can be completed. Like this, because we found out the K value. It is 0.00665. Now that we found out the proportional equation completely, or variation equation completely, let's answer the question. If borrowed amount is $120,000, what is this? Well, all I have to do is this computation, which is, yeah, of course, no surprise there. That's the standard solution. 4-step process. Step 1, the variation equation. Step 2, put the numbers in to find K, proportional constant. Put K back in to complete the equation. Here, we have a proportional equation, but we don't know the K value. Put the numbers in, so for K, okay, we found out the K value, so the variation equation is now complete. Answer the question in step 4. Put the number in, and then do your computation. This is a standard solution, which I'd much rather use. Okay, it's much harder way than doing this way, but this standard method can be extended over to joint variation and other far more complicated situations. Step 1, variation equation. Step 2, plug the numbers in and find K. Now that we have K, put this K back into the variation equation to complete it. And finally, answer the question. I'm using M for mortgage payment instead of P for payment. Yeah, all right. Is there visualization? Okay, visualization, all right. Not that big a deal. Now, how about an example on inverse variation? Okay. The maximum weight W that can be safely supported by a 2-inch by 4-inch piece of pine plank varies inversely with its length L. So the longer the plank, putting some weight in the middle, and more easily it'll break. So the longer the length, less strong it is. If the maximum support for 10 foot long 2x2 2x4 piece of pine is 500 pounds, what is the maximum weight that can be supported by the length of 25 feet? So 10 feet, 500 pounds, 25 feet, it's going to be weaker, right? But by how much? Well, let's consider a shortcut answer. 10 feet became 25 feet. Multiply by 2.5 right? Increased by 2.5-fold. Does it make sense? So 10 feet became 25. Let's see. Originally L1 was 10 feet and then L2 is 25, which means 2.5-fold increase. Now this is inverse variation, so the multiplication becomes division, or we are multiplying inversely, multiplying reciprocal. So maximum weight that was, let's see, 500. Well, this is inverse variation, so the multiplication must become division. No addition, subtraction, just multiplication and division only. So 500 divided by 2.5. And what is this? Well, you can calculate this. Punch this into calculator. 200. That's a short answer, a shortcut answer. And it works. Not that I suggest this. So 2.5 times the previous. So, and it's inverse variation. So divide by 2.5, you get the answer. But that's not the solution that I would suggest. I'd much rather do it to the standard solution, which is a 4-step method like this. The weight support is inversely proportional to the length. So that's the variation equation. Inverse variation. Now plug in the numbers to find K. 500 is K times 1/10. K is 500 times 10, 5,000. Okay, now that we found out K value, put this one into this variation equation to complete it. This is provisional equation. We have relation between W and L, but we don't know the provisional this proportional constant. We found out, so let's put it in. 5,000 divided by L, or if you prefer, times 1/L. Okay, all right. That's step 3. Finally, let's answer this question. What if L is now 25? Well, 5,000 divided by 25, 200. Same answer. Instead of just 1-step process, we are using 4-step process. What a waste. No, this is not a waste. This is a preparation of something to come, something far more important. So I would far more emphasize a standard solution. Get the variation equation, find K by plugging the values, plug the K back in to complete this variation equation. Now use the variation equation to answer the question. Remember the standard method. Both for direct and inverse variation, remember the standard solution.